Welcome back to my channel. Today's video is on the function y equals to x power 2n. I urge everyone to see my video on y equals to x square, as that video is the foundation of this video and every single properties of this y equals to x power 2n function is same as the function y equals to x square. So please check out the video on y equals to x square. With said that, for n equals to 2, suppose we have here, let me write it down. For n equals to 1, we have the function y equals to x square. The graph of this function is already well known. Now we want to find out the graph of the function n equals to 2. So that is y equals to x power 4. Similarly, y equals to x power 6, y equals to x power 8. So the even powers of the function x that we want to plot. So as I have already said that all the properties of the function y equals to x power 2n is same as the function y equals to x square. And for n equals to 2, we have the function y equals to x power 4. Similarly, x power 6, x power 8, x power 10, 12, 14, etc. Now, there are two parts. One is between -1 to 1 and another one is greater than 1 and less than -1. So if we draw the real line here like this, so real line can be divided into three parts. One part is this -1, x less than -1. Another part is this between -1 to 1, and the last part is greater than 1. Okay. So first let us see the interval -1 to 1. So for -1 to 1, we get this here. So as if we take an example like this, x equals to half, what we get? X square will give 1 by 4, x power 4 will give 16, x power 8 will give 1 by, here we have 16 square, that is 256, and so on. So here we can easily see that from here we can see that half is greater than 1 by 4 and 1 by 4 is greater than 1 by 16, and etc. So in the interval -1 to 1, that is the open -1 to 1 interval, the function satisfy these properties, which is x square greater than x power 4 greater than x power 6. Now for the next part, which is this part here, this part means union of this part and this part. So let me take two examples. One is 2 and another one is -2. So for 2, what happens here? So let me take it as 2. So for x equals to 2, what we have? We have 2 square, that is 4. 2 power 4 is obviously greater than 2 square. So it becomes this 2 power 4, 2 power 6, and so on. So as the power increases, the functions also increase. In the interval -1 to minus infinity to -1, union 1 to infinity. So here we have this inequality. Okay. And similarly for -2, so for suppose we have -2 here. So what happens for -2? Since these power are even powers, so all these will become positive. So so all the signs will become positive as it is the even power, and from that it already satisfies this inequality here. So again, in this interval we have this inequality. Okay. Now let us plot this function. So here I have already plotted the function. So starting from the function x square, the x square function is this one here, that is the black colored function, that is our x square function. So let me write it, that is the x square function. So what happens is that between the minus 1 to 1, so let me write here as minus 1 and 1, what happens is that x square is the largest function. That is, it has more magnitude than the other functions. And as it becomes x power 4, x power 6 and x power 8 and so on, it will lie in below of the previous function. So here we can see that the black line lies above, then lies the blue line, which is this x power 4, then lies the purple line, which is the x power 6, and lastly lies the x power 8 function, which is the lowest of these four functions. This happens between minus 1 to 1. Now, after 1, what happens is that the red function, which is this x power 8 function, becomes the highest one. Then we can see that the purple function, which is x power 6, it becomes the highest one. Next comes the function x power 4, and lastly comes the function x square. And same thing happens here for the x less than minus 1 interval, that means here. Okay, so let me write it. Here it is x power 4, x power 4, and here it is x power 6, and here it is x power 8. Okay, so this x power 2n function has two properties between one, which is the minus 1 to 1 interval, where the function satisfies a property, and for greater than 1 or less than minus 1, the function satisfies the same property. Now this function y equals to x power 2n has exactly same properties as the function y equals to x square. I would like to ask everyone to check out that video. And also in the next video, I'll be discussing about the function y equals to x power 2n minus 1, that is the odd powers. Thank you for watching this video. Please like and comment on this video and subscribe to my YouTube channel.